today we're going to look at section 8.1, adding and subtracting polynomials. The objective is to classify, add, and subtract polynomials. Let's take a look at problem 1. Finding the degree of a monomial. If we take a look at example A, where we have 5x, what does that mean when they ask what is the degree of each? Looking at 5x, we look at the letter x, we don't see a number next to the x, so it's actually a 1. So that exponent has a degree of 1. So if there's not a number listed or noted next to the x, we know that it's an invisible 1. The degree is then 1. Looking at the next example, B, where we have 6x to the third power y squared, what does it mean if I find the degree in that problem? How did they come up with the answer 5? What they did was they took exponent 3 and the y squared and they added them together. So 3 plus 2 equals 5, which gives it the 5th degree. If we take a look at the example C, we notice that there's a number without a letter. If that's the case, there's no letter, it's a 0 degree. That's like x to the 0 power, and the degree is a constant 0. So if you have a number without a letter with it, your degree is the 0 power. Let's take a look at the guide. A. What is the degree in this problem? The degree here is we have from A, we have an x, and what number is above the x? You have your invisible 1 of the x, and the y, another invisible 1. We add these two together, 1 plus 1 equals 2. So the degree in this problem would be 2. Let's take a look at problem number 2. Adding and subtracting. If we take a look at example A, how do you do that problem? Just like we did before. You add like terms to come up with our answer. We both have an x squared and some like terms. So all we're going to do is 3 plus 5 equals 8, and that is for the x squared. So 3x squared plus 5x squared gives me 8x squared. Combine like terms, which reads from. For example B, where we have 4x to the third power y minus x to the third power y, how do we get that answer? What we did was we take 4 x to the third power minus power y. What number goes in front of this x? Invisible 1. So they're both like terms. They both have an x to the third power, x to the third power, y. So all we need to do is to add our numbers in front. And we get 4 minus 1 equals 3. Keeping the units the same, we have x to the third power, y. Let's take a look at the guided problem. Look for the word sum. The sum being, that's correct, add. So I'm going to take these two numbers, negative 6x to the fourth power plus 11x to the fourth power. Are they the same terms? Yeah, they both have x to the fourth power, x to the fourth power. So now we just need to do is add our numbers. Negative 6 plus 11. Negative 6 plus 11 is correct. 5. Is that my final answer? Not quite. We need to add the like terms, which would be x to the fourth power. So my final answer would be 5x to the fourth power. Now let's take a look at the next problem. This one we want you to find the difference. What's difference mean? Correct. That would be when I subtract the two numbers. So if you have a problem that looks like 2x to the second power, y to the fourth power, minus 7x squared, y to the fourth, what do we do with this problem? Are they like terms? Let's see. X squared, y to the fourth, y to the fourth. So we have like terms, so now we just want to subtract our numbers. 2 minus 7 gives me negative 5. Then just carry over our like terms, x squared to the fourth. So we have x squared and y to the fourth would be our final answer. Here's a chart that would be helpful deciding what degree the equation is. If you look at the first one, degree of 0. There's no letter with that number, so the degree is 0. In the second example, 5x plus 9. The letter x has number 1 power, so it is the first degree. Looking at the next example, 4x squared plus 7x plus 3, the degree in this problem is 2. Even though that there's x squared and x to the first power, you don't add the two exponents. You look for the exponent that is the biggest in that problem, and that is your degree. The biggest x is x squared, so your degree is 2. Looking at the next example, 2x to the third power, your degree is 3 because that is the number, the x in that problem. Then the last problem, 8x to the fourth power minus 2x cubed plus 3x. The degree in that problem is, look for the biggest x, the exponent being 4. The degree is 4. So hopefully this will help you understand how do you figure out what is the degree in your problem when you have the same variable in the equation. And when you're asked how many terms does the equation have, what are the number of terms, that just relates to the number of terms in the problem. There's one number of this problem, so your term is 1. There's 2 in this equation, so your term is 2. Same thing for the next 3 problems. 1, 2, 3. The number of terms is 3. 1 term, 1 term. Remember 1 term. 1, 2, 3 coefficients. 3 terms. So hopefully that explains what the degree is and the number of terms given in the problem. Let's take a look at problem number 3. Classify polynomials. When you're given the equation 3x plus 4x squared, you want to classify this equation. What you need to do is move the number with the biggest exponent to the front and rewrite it as 4x squared plus 3x. You take a variable, the exponent, the biggest number, which was your x squared, and rewrite it in front, followed by 3x. Let's take a look at what you would do with this type of problem. The first thing you need to do is what? Look for the number, look for the exponent with the biggest power. That would be 5x to the third power. So I would rewrite that first. 5x to the third power. Where is the other exponent? The next lower power, that would be 4x and 7x. So we'll just write plus 4x plus 7x. Sorry about that. We have 1 extra x. Take that one away. And I want to put minus 1. So my answer would be 5x to the third power plus 4x plus 7x minus 1. Is that my final answer? Not quite. We have 2 variables that are like terms, and 4x and the 7x. So to get our final answer, we combine our like terms, and we'll end up with 5x to the third power plus 4 plus 7 gives me 11x minus 1. Now, 5x to the third power plus 11x minus 1 is the final answer.